Okay, so we are working on a stopping distance, and the problem states Arden City Police Department, and I'm just reading it from your notes right now, so you're on page 940. Arden City Police Department is offering special classes for interested high school students this summer. Elsa decides to enroll in an introductory forensic science class. On the first day, Dr. Suarez tells Elsa's class that they will perform an experiment at a local driving track. On the day of the experiment, a professional driver conducts multiple trial runs in which the driver drives down a straight track at a certain speed and then quickly applies the brakes. Elsa and her classmates record the length of the skid mark left by the car based on the speed. So if you're looking at this, if we just examine the table first, we have our car speed, which is our x, and we have the length of the skid mark, which is y. So if you're going 25 miles per hour, it takes you about 20 feet to stop. This is all real life, like they went out on the track and they tested it. 60 miles per hour, 150 feet to stop, and then so forth. So as you can see, as your speed gets faster, as you go faster, your length of your skid mark is also going to increase. So I set up the graph right here, and you can set that up now for number 1. Again, for our car speed, we needed about 0 to 110, so I counted by 30s, or technically 15s, because see how I didn't left those marks blank. And then I counted by 50s on the y. Now my x is my speed, so I'm going to write that on my graph. And up here is my length in feet. So I'm just going to kind of draw an arrow. It's kind of really tight here. So just draw an arrow there so I know that that's my length of feet, length of skid mark in feet. So now I'm going to plot each of these points. And again, use your best estimation for these because you can't be perfect. 25 and 20. So I go over to 25 and then up to about 20. 30, 35, 45, 79, 55, 130. And notice how my graph is increasing. 60, 150. That's an easy one. 75, 244. 90, 336. 100, 410. And then 110, 490. That's about right here. So again, look at the graph. We have to decide whether this looks more like a linear graph, an exponential graph. And now we're going to learn something new where we're going to talk about something called the R squared. I know a lot of you have always asked me, is it R or R squared that we look at when we talk about the correlation coefficient? Well, now we're going to steer away from R and we're going to look at R squared. So go to that regular worksheet that we printed off for you and we're going to go to the notes on there. So we're just doing these 3 questions right here. Well, 2 questions. So the R squared is called the coefficient of determination, okay? And again, it'll appear after or before the R when you find your stat. It measures the strength of the relationship between the original data and the regression equation, okay? The strength is the difference here, okay? Now your values, here's something else that's different. The values of R squared range from 0 to 1. There are decimals in between, of course, but there's no negatives this time. It measures the strength, so how close are they? There's not going to be a negative or positive, or negative. It's not going to tell you what direction it goes. Again, it talks about the strength. So 0 to 1, the closer the value is to 1, the better fit of the regression equation. So same kind of idea. If it's like 0.99, it's strong. So what we're going to do is we're going to go to our warm-up, and we're going to do that one first before we go back to that problem we were just solving. So calculate the coefficient of determination for each regression equation in the warm-up. I don't know why I said above. We're doing it in the warm-up, which is on your paper, so don't worry about it. Okay, so we're going to do a linear one, and we're going to decide what R squared equals. Then we're going to do an exponential. R squared equals. And then we're going to do a quadratic. r squared equals. And we're going to find all these. Now, here's the new part here. We've done linear, and remember it's stat over 4, enter. We did exponential. We practiced that a lot yesterday. It was stat over 0, enter. Now here's the quadratic. It's new. It's stat over 5, enter. So same steps. All you do is you hit 5 instead. So I'm going to go to my calculator. I'm going to clear it out. Second plus 4, enter. Stat, enter. And I'm going to enter in the values of the warm-up. So we're going to use these values that you should have on your warm-up right here. So again, we counted by tens, right? So we counted by tens, so that's what I'm going to type in the calculator here. We're going to do 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then 110. It's my L1, that was my X, and now I'm going to do my L2s. We have 4 2s in a row. 2 3s, 4, 6, 15, 25, 33, and 44. Okay, so now that we have that, we're going to do our next step. And the first one is we're going to find linear. So we do stat over 4. And remember, you just need 1 enter. I'm going to hit a couple more times. And then I'm looking for my r squared. So here's my r squared. Again, it's right above the r. And I'm going to do 3 decimal places. So it's 0.724. So I'm going to write that down over here. It's still in that worksheet. So let's change the color to blue, I guess. 0.724. And now I'm going to go back to my calculator, and I'm not going to clear anything. I'm just going to hit stat over 0, enter. And this will give me my exponential. So my r squared for my exponential is 0.889. So 0.889. And now I'm going to do my quadratic, the new one, but again, nothing major. I do everything the same except I hit stat over, and then I'm going to come down here to 5. See how it says quadratic. So I'm going to do 5, enter. And I get 0.975. And again, that's the, they only have r squared for quadratic, so that's what I'm going to write, 0.975. So now, for question B, it says, what regression equation best fits the data? How do you know? Well, let's look at these. Linear is 0.724, exponential is 0.889, and quadratic is 0.975. Well, if I look at those, which one's closer to 1? The quadratic. So that's what we're going to write. Quadratic because it has the highest r value, r squared value. All right, so that was us practicing it. Now we're going to go back to our book notes. So go back to our book notes and turn to page 941. And you should see question number 2. Now question number 2 is we want to analyze the scatter plot and decide which one works best. So we need to decide whether we like linear best. So we're going to do linear. We're going to write the equation down for linear. We're going to write it down for exponential. And then we're going to write it down for quadratic. And again, remember, linear is 4, exponential is 0, and quadratic is 5. So we go back to our calculator. We're going to clear this out. Second plus 4, enter. stat, enter, and I'm going to start entering the data in. So that's my x values, and now I'm going to do my L2, my y values. And now I'm going to find my linear first. It's easier just to start with linear and then work your way down. So stat over 4, enter. So linear. I'm going to write my equation and I'm going to write my r squared value. So again, the linear equations, it tells you the format, ax plus b. So I put my a in, x plus, I substitute my b in, and my r squared. So linear is 5.53x minus 152.44. And the r squared is 0.97. Okay, so that's linear. Now I go back to the calculator. I'm going to do stat over 0, enter. Again, I didn't have to type in the data again. It's still in there. So I look for this equation. Again, it tells me the general format, a parenthesis b to the x. And then my r squared is right here, 0.94. So it's going to be 13.45 parenthesis 1.04 to the x, and my r squared is 0.94. Now I'm going to do it again, and I'm going to use quadratic. So I do stat over 5, enter. Now quadratic equations, you know standard form, ax squared plus bx plus c. So we have an a value to substitute in, a b, and a c. Okay, so we have to do all three. A, x squared plus your b, x plus your c. So I'm going to write that down. So we're going to do 0.034x squared plus 0.95x minus 26.64. And my r squared is 0.99. All right, well, looking at this, which one has the highest r squared value? You can see it's quadratic. Now you can see that it's also really close, 0.97, 0.94, 0.99. That's why you got to do 2 decimal places. Sometimes you might even have to do 3, depending on the problem. So quadratic is best because it's closest to 1. And there we go. So that's what you're going to do. Now, B, describe the domain and range, and we've done this a lot so far. So we have our domain, and it's going to be blank is less than or equal to x, which is less than or equal to blank, and then our range is going to be blank is less than or equal to y, which is less than or equal to blank. So remember what we look for range. We look for the for domain, you look for the smallest x and then the largest x. So I go back to my table. My smallest x was 25 and my largest was 110. So 25, 110. Now I do the same thing except I look at my y column. 20 is my smallest number and 490 was my highest. And there's my domain and range. All right, flip your paper over to 942. Now, for this problem, They like to mess with our brain a little bit. Now what they're going to do is they are going to switch the x and y. So all the y's are now the x's and all the x's are the y's. So in our table, that's what we need to focus on. So we're going to do, again, a linear. We're going to do an exponential. And we're going to do a quadratic, and we're going to decide which one's best. So I need to go back to my calculator. I need to clear this out. So second plus 4, enter. Stat, enter. And now I need to enter my data in, and I'm going to show you the data. But I need this to be flipped. So the y's are going over here in the L1, and these are going in the L2 now. So our y's start with 20, 35, 79, 130, 150, 244, 36, 410, 490. Then if I go over to L2, now we do our car speed, 25, 30, 45, 55, 60, 75, 90, 100, and 110. So I go back, I'm going to start with linear. So I need to type it in. I already typed it in, and I'm going to do number 4, remember. So linear is 4, exponential 0, quadratic's 5. So linear, so stat over 4, enter. And I'm going to write the equation and the r squared value. So here's my equation again. Linear is ax plus b. So it's going to be 0.18x plus 28.36, and my r squared is 0.98. Now I'm going to do exponential. Stat over 0, enter. No entering the data in again. Exponential is, oops, did it too many times. A times b to the x, and again I want my r squared. So 31.94, we're going to do 1.003 to the x, and r squared is 0.88. So a little lower. Right now linear is still in the lead with 0.98. So I'm going to do stat over 5, enter. Okay, and then I'm going to write these in, a, b, and c, and then r squared. Now, a few people always ask me about e to the negative 4. That just means we're moving our decimal point 4 places this way. So a, b, and c. So it's going to look like this. Again, feel free to ask us about that one. I know it can look a little weird. Alright, and then here's our quadratic. So you can see which one's the winner. Quadratic is the highest r squared value. Alright, so let's see what they want us to do with it. So you can cross off B, hooray, that one's done. And then we're going to do C, and I'm just going to rewrite the equation here. Because remember, this was our one that was in the lead. This one had the highest r squared value. And now what we're going to do is we're just going to substitute 50 in for x, 175 in for x, 350 in for x. I'm going to do this first one. You're going to be in charge of these two. So negative 0.30, and then parenthesis 50 squared, plus 0.27 and then parenthesis 50 plus 21.79, and you should get about 34.82. Now try it with 175 and through 50. Yes, you need those parentheses also. When you finish this, you don't have to do any more of the notes packet, but you need to go back to that loose leaf paper that we passed out that we started notes on and answer questions 1 and 2, and then that will be it.